Hi, this is Linda Shea with Drilling Contractor. I'm at the 2025 IADC SPE, MPD, and UBO conference in Mexico City. I have with me Santiago Callerio, who is a graduate research assistant with UT Austin. Santiago, thank you for being here.
Hi, Linda. Thank you so much for inviting me for this section of Drilling Contractor. I'm very happy to be here.
So you talked this morning at the conference about the development of a virtual trip tank. Can you tell me what was the problem that you were trying to solve by the development of this VTT?
Yes. So essentially, every MPD system out there already has a Callerio flow meter to measure flow out of the well. And then measuring flow out and comparing it to flow in provides a valuable tool for early kick or loss event detection, right? If we integrate that difference between the flow in and flow out a long time, we get what we call a virtual trip tank, which is a volume measurement that mimics the behavior of a small pit or trip tank, and it's way more accurate than the PVT, than the active PVT measurement. However, although every MPD system offers these valuable tools, which are supposed to be precise, consistent, and automated, we all know that there's some tweaking that goes behind it to actually calibrate those measurements because of differences in pump efficiency throughout the operation. Eventually, what will happen is because of that difference in the pump efficiency, the VTT starts drifting away, signaling either kicks or losses in stable conditions. So what we're trying to solve is to implement an auto-calibration algorithm that allows the user to auto-calibrate those measurements to have a reliable VTT measurement throughout the operation. In that sense, removing that tweaking and that user bias that goes into the calibration process. And apart from that, the secondary objective is to provide a reliable measurement to measure the tripping progression, since tripping nowadays with MPD is still done with conventional trip tanks and Excel sheets. And what we want to do is automate the process and provide a valuable tool out there that users can handle in real time to accurately detect kicks, and then by that reducing false alarms and also detection time. So improving the monitoring of potential well control risk during tripping operations.
Can you give us a brief overview of how the virtual trip tank actually works?
So actually, the real-time flowing calibration method is based on the mass conservation principle. So essentially, if there are no additional sources or sinks acting in the well giving rise to influxes or losses, and there's no activity such as pipe movement inside the well that can disrupt that mass balance, then the flow out should accurately reflect the flow in. So the basis for the flow in calibration is to find steady state parameters across the operations where the flow in and flow out has the least possible deviations, or let's say parameter ranges where the flow in and the flow out are sufficiently close in the way the signals look like. And then having those periods already isolated and then using the flow out as the ground truth, then generate the calibrated flow in measurement. So essentially what we're doing is bringing the flow in closer to what the flow out is telling us, which is the Coriolis flow meter measurement.
So I understand that you've already done some testing with this VTT. Can you tell us about the kind of results you've seen?
Yes. So all the development of the algorithm was done with actual operational data. So we trust that the system can actually work with real field data. And the results were quite good. We had a strong improvement both in the error and the drift of the VTT. We first improved the error by 85%. We reduced the drift of the measurement by 97%. And we've also improved the R squared by 94%, which actually measures the correspondence of the actual measured VTT to the expected displacement that we're modeling, the theoretical displacement. So essentially, we removed the non-quantified measurement drifting from the VTT, which makes you question, whenever you're measuring a volume, how much of that volume is it actually a kick and not the drifting of the measurement. And besides that, we also automated the process, making it consistent and repeatable, and thereby removing the user bias from the calibration process and basically removing the man behind the curtain from the process, right? So we've made it easier for the users and something that you could run in any type of surface back pressure operation right now.
So what do you have planned for the future development of this technology?
Okay, thank you, Linda. That's a great question. So first, let me tell you that this project was developed within the Rapid Research Consortium of the University of Texas at Austin. And this was done in association or in collaboration with our sponsor, Stasis Drilling Solutions, which provided the motivation and the data for the development of this project. So basically, the plan forward contemplates the deployment of the system before end of year within Stasis Drilling operations to capture how the system performance is in real time. For that, we're working together with the Stasis Drilling automation and software team. And besides that, we also plan to, well, right now, the system is mainly based on tripping operations. So what we plan to do is to extend that workflow into the actual drilling operation, considering drilling ahead situations, connections, and dynamic testing, such as dynamic FIT, dynamic leak-off tests, or dynamic pore pressure tests that you can do with an MPD system to provide a much more accurate measurement during the test, and then enhancing the performance and precision of the system related to the Coriolis flow meter measurements. So we think that that's where the real value comes in.
Well, sounds like a very exciting technology. Thank you for sharing that with us, and good luck on the future.
Okay, thank you so much, Linda, for this invitation.
And thank you for joining us on drillingcontractor.org.